Now that you have ensured that none of the assumptions of regression have been violated, you can now go through your model to look at how good it is at explaining the data that you have. The first question you need to ask is if your model is significant. When you run a regression analysis in a statistical software package, you will be provided with an ANOVA table that evaluates your model's significance. The omnibus test for significance in a regression analysis is the F statistic. This is calculated by using the mean squares regression divided by the mean squares residual. The next slide will go through the parts that contribute to getting these values from the values provided in your ANOVA table. The mean squares regression is going to come from your sum of squares regression divided by the degrees of freedom regression, which is equal to k, or the number of predictor variables. The mean squares residual is determined by the sum of squares residual divided by the degrees of freedom residual. And that's going to be determined by the number of observations minus the number of predictor variables minus 1. So n minus k minus 1. And so now you're able to take these values to calculate your F value. Typically, you're going to want your F value to be a larger value. Your F test is used to evaluate the null hypothesis that there is not a linear relationship and the alternate hypothesis that at least one independent variable has a linear relationship. So to move forward with using or applying your model, you must be able to reject that null hypothesis. Otherwise, any interpretation that you make based on that model is not going to be best supported by your model because you're violating the assumption that you have linear relationships. So remember, that's an underlying assumption for multiple linear regression. Here's how the F value is calculated. Your statistical software package is going to do this for you in a ANOVA table, but this is where those numbers are coming from. The next thing you want to look at after determining if the model is significant is how well the model fits the data. R squared is a description of how well the data and the model fit together. Think about how well your shoes fit. You're not going to make your shoes conform to your feet, and you're not going to make your feet conform to your shoes. But you do need to assess how well they fit together when you decide whether or not that's a good pair of shoes for you. We do the same thing with our data. Here's another form of the equation to calculate your R squared value. So we have the regression sum of squares, which is the difference between the predicted value and the average value squared. This is essentially the difference between the line that you draw for the model and the average value divided by the total sum of squares, which is the sum of the squared differences between the actual value and the average value. Similar to simple regression, the R squared statistic can be calculated as an indication of the proportion of your variation in the dependent variable that is explained by all of the variables in your regression model. However, this measures an over-optimistic indicator of the explanatory value of your variables. The R squared statistic is going to attempt to adjust for that. That's why it's called adjusted R squared, to give you a more representative measure of the predictive power of the model by taking into account the number of predictors that we had in our sample. Once we do this, we also need to look at the outputs with the t-values and the significance of them. If you remember, I said the significance of 0.042 for bark thickness means that it's not really a very strong variable in that model. So you should consider running your model with and without your bark thickness.